Hi, I'm Brodie. Mitch and I are in the shop. Welcome back. It's good to have you here. We're working on the Aermacchi today, and I drilled some holes in the countershaft sprocket, but it wasn't easy. I'm going to give you a little slideshow of what happened. It's a 17 tooth, so I drilled 17 holes. I set the sprocket up in the mill, and I don't know if you can see, I drilled a total of 10 holes, and they went really fine. And then I tried to drill the 5 holes here, and that didn't work. The metal was so hard. So I concluded that what happened when they heat treated the sprocket, this part from here to here was much harder than it was over here. So what I did was I heated it up until it was red hot, and then I got my pliers and I put it into the lime for a couple of hours because the lime helps it to cool down really slowly. Then after it was normalized, that's what I'll call it, I drilled the holes and the holes went fine, and then I held it in my cordless drill and I spun it round. I got my big torch out. I heated it up till almost red hot, and then I stuck it into this vat of used engine oil. So that's what I did. That's how I got the holes in the sprocket. So I saved almost an ounce. That's a lot on one little piece. So that's what's going on with the sprocket. I've also done something on the clutch. So here we have a stock hub, a stock clutch hub. And this is the one that I've worked on. Now they don't look a whole lot different, but got my weighing scale here. So it's 1,230 grams basically. It's 9.9. We'll call that 1,230 grams. So these two look the same, don't they? But look at this, 981. So that's a bit of a weight saving. I think it's a little over half a pound. So when I was machining this down, I was turning it pretty slow. It's a pretty hard piece of metal, and so how you can tell in a way how hard it is, it's got a ring to it. Can you hear that? It's almost like a bell. Well, it does sound like a bell. So it's pretty hard. So I used a slow speed, a carbide tool. And so now I don't have carbide to drill the hole, so we're going to have to go pretty slow. We'll set it up in the mill. As I was machining it, I had to put a piece of wood in there. There's wood, there's a little bit piece of cardboard in there just to add a little bit more of an interface there. And it stopped the ringing. And then I also machined this side of it as well. So I took off quite a bit of weight. Let's go over to the mill now. We'll set it up a little bit more and I'll see if I can drill the holes. I've never tried drilling this before with just basically regular drill bits. So let's go see what happens. I made up a drawing. So this is the clutch hub, like so. That's how the clutch hub is. So I had to know how much I was taking off here. And these are the sizes, how large it was. Like it was 212 and I got it down to 182. So how do you measure that? Because that's, like I can't measure that there or there. So at first what I was doing was this. I got my calipers here and I was measuring like so. And then I decided, okay, that's not really accurate. I want to do it more accurately. I took my 1:2 mic, and that's the 1 inch. It's a standard. It lets me know if my mic is calibrated. So that is exactly 1 inch. So what I did was I put this like this, and then putting that inch piece in there, now I can measure how thick that is. Like that. See that? Now I'm actually measuring from here to here. And then when I wanted to measure this here, I had another system going. That can go through like that. There we go. And there is just enough room in there. See that? I just got enough room so that I can move the mic. So if you're ever in a hard to get space, there, see that? That's going to be accurate there. That's what I did. So we're going to go over to the mill now. See if we can drill holes in hard metal. So we're on the low speed, we're about 300 and something RPM. I sharpened the center drill this morning. Looks like it's cutting fine. Every 45 degrees, I'm doing 8 holes. We're going to find out now how much weight we saved. I think Mitch said he estimated we saved 96 grams and I estimated 110. So let's see who's right. Our last known weight, 981, and we are at, we only saved 60 grams, so we were both really optimistic. So we got it down to 920 grams. I still have to take off the burrs, but I'm not going to do that right now. So I think we're going to mount the Tach on the race bike. That seems like a good project for today. You're probably wondering, with all this stuff going on, yes, we're going to mount a Tach soon. I ordered a Tach off eBay. It's an automator, and that's what I've used on other race bikes. It showed up. And it's a little different than what I was expecting. I like the face. All the face is fine, but how it mounts, I guess I didn't check it out enough. I think it's more of an automotive application rather than motorcycles, but anyway, how it mounts is going to be the same. There's this rubber piece here, and that goes into here. And then what I'm going to do is because I've mounted these previously, and this is the weak point here. It breaks. So we're going to add a reinforcement out here and make this a little longer. And that's basically how that works. It goes like so. And it clamps. And then this goes here. There's going to be a hole drilled in here. And that's basically how it's going to mount. So in the comments, someone said, this is way too long. You could have shortened that up 3 inches, but no, that's where the Tach goes. It's meant to be like that. So let's see what we can do. I've got some 1/8 inch cold rolled. We're going to make a couple pieces here. Let's see what happens. This is CAD design with cardboard. Let's make a 6 mil hole now. I've got some 6 mil ready rod, and I'm trying to space it so that when this goes on there, it's the right spacing and it holds it nicely. Okay, see there, I need to go out a little bit more because it's hanging up right here. So I'll open it up a little bit and then we can tack it on. I'll TIG tack it on and then we'll nickel silver it. This needs to be 3/16 wide. That's what I'm doing. 3/16 is 189, 190. So we have another 185 thou to come off. So here's the final size. Oh, can you see that? 0. Looks good. Okay, this piece here goes in between those two front struts. This piece up here is going to hold the tack. Okay, I'll do it that way. There's been people telling me to do it this way. But I can do it both ways. I'll do some final sanding and then it'll go out for anodizing and all that. So in the meantime, I'm going to mount the tack on this. I'll just file out these edges here. Take off the burrs. That's going to clamp on like that. So we need a spacer for each side. So I'll get my vernier, we'll measure. Oh, 1.2, a little bit less. So if each one was 600 thou, that could work. Okay, we have spacers. Let's see if it's a fit. There's a little bit of squish there. One mount. Let's see what happens. So there's a little bit of friction as this goes down, but I will drill a hole. But right now, it's not going to go anywhere. So it's a little bit shock mounted with that rubber there. You can see there's a little bit of movement. So that's it. That's our Tach mount all done. Thank you for watching. We appreciate it. And Mitch and I like coffee. You know that. See you next time. Have a good week. Bye.